we're still going through the classification theorem of compact surfaces, and after the second step, we saw that every surface can be represented by a plane model that does not have a label followed by its inverse in the plane model. Okay, so what is step 3? Now, let me give you maybe explain step 3 on an example. So I'm going to use a plane model with 6 edges, so a hexagon. So here is how it's going to go. This is going to be A, and this is also an A, so they're supposed to be glued like this. Then this is going to be a C, and this is also a C. So they're supposed to be glued like this. And this is B, this is B. So they're supposed to be glued like this. So I guess you can imagine how all the glues are going to work, and you will see that the surface is actually a torus. But in any case, let me explain what step 3 is about. It is important to realize that when we glue, say, A to A, then of course this point, which is in the tail of A, is going to be glued to this point, which is also in the tail of A. Right? So let me label it somehow. That this point is going to be on the actual surface. These 2 points that are different vertices of the hexagon, on the actual surface, they are going to be glued together, and they are going to represent the same point on the actual surface. So let's say that, let's call it P. Right? So this P is going to be found in the tail of arrow A. Right? So in the tail of A. At the same time, let's look at B. So P is also found in the tail of B. But then B is going to be glued to this B, so which means that here we also have tail of B, which means that this is also a P. Well, but here we can look that we can see that P is also in the tail of C, and then we can find another copy of the tail of C, which is here. So which means that this is also a P. But then this copy of P is in the head of B. So we can find another copy of the head of B, which is here. And this is also P, and this is the tail of A, which have already been used. So the cycle is closed. Right? So it means that all these 4 different vertices of the polygon, they represent the same point on the actual surface, and the neighborhood of this this point on the surface looks like this. So we are going to have a part of A, then we're going to have here B, then we can just kind of, so imagine that from here, yeah, maybe it's better to go to the other direction. So, well, maybe it's okay. So that we are moving around the point P on the surface in the clockwise direction, right? So then, first we are going to meet the tail of A. So then we are going to move to the tail of B. So then we are going to jump to another copy of the tail of B, and we are still moving in the same counterclockwise, sorry, in the clockwise direction. So then the next thing that we are meeting is C. Then we are jumping to the other copy of C, and we are still moving. Now we meet the head of B, and then we are going to jump to the head of B, and then continue moving in the clockwise direction, and then we are going to jump to the tail of A. So it means that a little neighborhood of this point P on the surface looks like this. So if we move around it in the clockwise direction, then we are going to see tail of A, then tail of B, then tail of C, and then head of B, and then again tail of A. Yeah, so notice that there are two copies of B, which means that somewhere far on the surface, so there is a loop that is really none of our concern at the moment. So the important part is that these four different points on the polygon, they represent the same point on the surface. But that's not it, right? Because we also have two other vertices of the polygon that apparently represent different points. So this is, say, some other point, maybe Q. But then Q is found in the head of A, and that's another copy of the head of A. So this is also Q. Well, in step 3, we're going to kind of reassemble our surface. So we're going to cut some part of this polygon, and then we're going to glue it back in a different in a different way to change this number. So now there are 4 copies of the vertex P and 2 copies of the vertex Q. So what I'm going to show is that it is always possible to reduce the number of copies of one vertex in favor of the other vertex. So in other words, we're going to make 5 copies of P and only 1 copy of Q. And so in order to do this, what we are going to have to do, well, let me say cut some triangle. Let me delete these little arrows. So I'm going to cut this triangle out of the surface. So imagine that our surface was originally made of triangles. So this was probably a triangle, so another triangle here, another triangle here, and so on. And then we glued them back into this polygon. But of course, we could reassemble them. So we could remove this triangle and attach it to another place. So for instance, I'm going to cut a triangle such that it has this vertex Q and glue it back to another copy of this vertex Q. So then, because then the idea is that after this operation, these 2 different copies of Q, they are going to become just 1 copy of Q. Right? So in order to do this, what I'm going to do, I'm going to say introduce. So when I'm going to cut it here, so which means I really need to introduce some new edge, say D. And then I'm going to just take delete it here and move it here, right? So I'm going to move it to this. Okay, so let me maybe make a dotted triangle. So I'm going to attach it here, and I'm going to glue it here along this edge A. And so in this triangle, I'm going to have A. Then besides A, I'm going to have D here and C here. Well, I guess you can imagine that I'm going to move it like this. So A is going to point upward. So this is going to be C. This is going to be D. Well, just to make sure that we don't make any mistakes. So C points towards the head of A. So this is the head of A, and C points towards the head of A. And D points, tail of D is same as tail of A. So it means that this is D. Alright, so I'm going to remove this and glue it here. So let me probably just to clarify that I am deleting this part of the hexagon, and then I'm going to glue it again, but to a different place in the hexagon. So remember that the original surface is still the same, because the original surface was probably made out of several triangles. So maybe this triangle, this triangle, this triangle, and this triangle. So then this hexagon is just a particular way to glue these triangles together. But now we are going to just reshuffle them. But of course, since the triangles are the same, the original surface is still also the same. Okay? So what happens after I move this triangle from here to here? Right? I'm going to have this D. This is going to be B. So this D, this B. Then I'm going to have C. All right. So after C, I need to since I'm touching this triangle here, I'm going to have C and D. So now this C points in the opposite direction to this C. And this D, it points to this direction, and here I have B, so it looks like this. But at the same time, notice that this points, this was P, this was P, this is P, this is P, and this point, the point that we are touching here. So notice that when we move to this triangle here, so this one kind of copy of P, it multiplies and becomes two copies of P. So one remains here, it's from this side. Another one that is on this triangle, it moves here, and this is also a P. And so which means that this is P and this is Q. And so by doing this operation, we increase the number of copies of P and decrease the number of copies of Q. In this case, since there were just two copies of Q, after we apply this, there's going to be just one copy of Q, and if you think about it a little bit, you will realize that the only possibility for when we can have just one copy of a vertex here, that a vertex of the polygon that is not glued to any other vertex, it is only possible in this case when there are two edges with the same label that point right towards it. So, but then it means that here we have the portion C inverse. So here we have C inverse, and then later, of course, we can delete them, so we can just cancel them, and then the remaining part of the plane model is going to be, this is going to be B, this is going to be D, this is going to be B, and this is going to be D, and now you see that it is indeed a torus. But the main lesson here is that if we have several kind of labels on the vertices, that vertices of the original polygon, they correspond to several different points on the surface. Right? So then we can take the set of vertices that correspond to the first point on the surface, and the set of vertices that correspond to another point on the surface, and then we can rearrange the triangles so that the first set is increased by 1 and the second set is decreased by 1. So, and then by applying this operation many times, we can always get rid of all extra vertices, and then in the end, so the end result of this operation, when we combine it with deleting C and C inverse, when we combine it with step 2, so plus repeating step 2 if necessary, the end result of this is going to be that all vertices of the plane model, they represent the same point on the surface. So let me write it, plane model, just one point on the surface. And that's the end of step 3.